For the last problem on quiz 8, we are given two functions, f of x equals the square root of x and g of x equals 2 minus the square root of x plus 1. The first thing we're asked to do is to describe the transformations. So what I like to do is I like to circle them where they show up in the algebraic representation of the function. So you can do them in kind of lots of orders, but you'll notice that there's a plus 1 here. There's this minus here, and there's this 2 there. So for the first piece, we have that x plus 1 is a shift to the left 1 unit. Okay, so that is a transformation that impacts the x coordinates. Then we have the minus is a reflection in the x-axis. We know that it's the x-axis, not the y-axis, because the minus is on the outside. And then the 2 is a shift up 2 units. Okay, so now let's go over here and graph. So here are my axes. So what I'm very hopeful with is that you remember the shape of the square root of x. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. So there is the shape of the pre-transformed graph. Okay, so that's f of x. And then in blue, g of x, right? So how do we get to every single point? We're going to take every point. We're going to shift it left 1 unit. So I'm going to do it point by point. So 0, 0 is going to get shifted left 1 unit. Nothing happens when that's reflected in the x-axis because it's still on the x-axis. And then it's going to get shifted up 2 units. So the origin gets transformed to this point there, negative 1, 2. Now 1, 1, watch what happens there. It gets shifted left 1 unit. Then it gets reflected in the x-axis. So right now it's here. And then it's going to get shifted up 2 units, which actually takes it right back here. So the point 1, 1 gets transformed to this point. Lastly, 4, 2, shift left 1 unit, reflect in the x-axis, shift up 2 units. So that ends up there. So what this does is this actually fleshes out the shape for us, and sure enough, we're used to seeing this by now. It's the same shape, but transformed. So let's talk about domains and ranges. The domain of f is everything starting from 0 to infinity. And the same is true of the range of f, right? So again, for the domain, we're looking at the x-coordinates of the points of the graph. For the range, we're looking at the y-coordinates of the points on the graph. The domain of g, interesting. So you see now, instead of starting at 0 and going to infinity, the domain of g starts at negative 1. That's the shift to the left that we're seeing there. And then the range of g, rather than going from 0 up, it actually comes up to 2 and then stops. So what you see there is both the reflection in the x-axis and the shift up 2 units. So finally, for the bonus, to do the coordinate analysis, we look at what happened to every point. So every point's x-coordinate, by being shifted to the left 1 unit, it went down by 1. So the x-coordinates went from x to x minus 1. And then y, well, first the y-coordinate was made negative. So that would become negative y. And then we add 2 to it. So you can either write negative y plus 2, or you can write 2 minus y. So that concludes the solution for problem 3.